Well, good morning, ladies and gentlemen. Mr. Kruger coming at you this time for the first time for Elch 2 Extended. Today we're going to be doing lesson 1.3. Lesson 1.3 is kind of a quick little brush over solving linear equations and talking about slope. Okay, so what you're going to be doing today is obviously you're going to watch this video, and then when you're done with the video, you should be able to complete the 1.3 try on your own TOEO, as we call it, the assignment. So let's get rolling into it. Basically, your note sheet is as follows. What we're supposed to do is solve each of the following linear equations. And just to refresh your memory, what that means is get the variable by itself. That's all that really means. Get the x, get the y, get the b, get the n in this case, all by itself on one side. And in order to do that, we just follow the order of operations on both sides. So the first thing I'm going to do is I'm going to put my b's together. So I have 1 equals 1 minus 4b. And then I'm going to put my like terms together. Now I'm going to subtract 1 from each side. And I'm going to get 0 equals negative 4b. And of course, I need to divide, obviously, by negative 4 here. And b is going to equal 0 divided by negative 4 is 0. 0 divided by anything is 0. Something divided by 0, that's a whole different ballgame. That's undefined. Number 2. When we're looking at number 2, I was taught as a very young math student in the elementary school. All your teachers will say fractions are your friends. They are. But I was taught as a young lad to eliminate my fractions. Now, what I'm doing is I'm looking for the least common multiple between my denominators, between 3 and 12. And I'm going to show you an extra step today that I'll go through and I do mental math with it, but actually the least common multiple of 3 and 12 is 12. So what I'm going to do is I'm going to multiply this entire equation by the number 12. And the next step I'm going to show you, I'm probably never going to do again. But what that does, that means I have 11 over 12 times 12 equals n times 12 plus 5 over 3 times 12 minus 1 times 12, okay? This would all be mental math typically. Nice thing here is this 12 wipes out that 12, and I have 11 equals n times 12, well, that's just 12n, plus, well, when I'm looking at this, here, 5 over 3 times 12 over 1, I can cross simplify that 3 will reduce with that 12 and call it 4. So I'm really looking at 5 times 4 to get 20 minus 1 times 12 is 12. Typically, I would go straight from this step and I would mental math these fractions right here in my head, and I would just go straight down to here. Then I'm going to put my like terms together here, and I'm going to have 11 equals 12n. What is that? 20 minus 12, that's plus 8. I am hence going to subtract 8 from both sides. And 11 minus 8 would be 3 equals 12n. Of course, I have to divide by 12. Okay. And I'm going to get n equals, because the 12 is reduced, well, 3 over 12, because it's a fraction, we always write our fraction in simplest form. That's 1/4. Okay. And then the next example, what we have is this one I would do a little bit different. Okay, notice the difference here. I have two fractions. The example that I had before, I had two fractions plus other numbers, so I wanted to get rid of it. Bottom line, I had more than one fraction on each side. Here, if I have one fraction on each side, that's really called a proportion. And how you solve a proportion is you cross multiply. And that's only for a proportion, two equivalent fractions. So what I'm going to do is I'm going to take 5 times p. Well, that gives me 5p that equals, when I cross multiply here, technically I have 3 times the quantity, p minus 6, and I'm writing this step out. I typically would mental math that, but it's important that I see that 3 is times p and the 6. I need to distribute that. So I'm going to have 5p equals 3p minus 18. I have no like terms to collect, so I'm going to subtract my 3p and get that over with my 5p to get those terms together, and I have 2 p's equaling negative 18, and then I divide by 2, those sides cancel out, I get p equals negative 18 divided by 2 is negative 9. And remember, you can always take that value for p, plug it back into the original equation, and you should get a true statement. Next thing we're going to run into here is, because we're talking about linear equations, slope is a big part of lines, okay? When you get into upper level math into calculus, you're going to find out slope is a huge part of curves as well. They have it too, but we're going to find the slope in the given situation. So what we have here is we have 2 points. And to find the slope between 2 points, if you remember the slope formula, which you are really expected to truly remember, is m talks about slope by taking y2 minus y1 over x2 minus x1, where I have any point, and my points are x1, y1. Well, and my other point is x2, y2. So what I always like to do is I always like to come up and say that's x1, that's y1, that's x2, that's y2, and then I just plug straight into my formula where m would equal y2 minus y1, so I have negative 8 minus 3 over x2 minus x1, which is going to be 3 minus negative 7. Notice how I didn't cheat. I wrote minus and I put the negative 7 in there, because anytime you run into a double negative, minus a negative actually is a positive, right? So that's going to give us negative 8 minus 3 gives us negative 11 over, it's really 3 plus 7, 10. So my slope m equals negative 11 tenths, and that would be the slope between those 2 points, okay? We have a couple more scenarios to look at. Find the slope in the given situation of a line that is perpendicular to this line. Okay, well, remember, when you're talking about lines, remember your favorite line. Remember your favorite form of a line, y equals mx plus b, where slope is tagged to your x value, okay? Just remember that. Something else we have to remember. We have to remember perpendicular lines. And in math, that's how we say perpendicular, your upside down T. Lines, they have opposite reciprocal slopes. Okay, example. If m equaled a over b, perpendicular to that would be m would equal negative b over a. So I just change the sign and I flip it. One other thing we're not talking about right here, but I'm just going to refresh your memory. Parallel lines. And in geometry, I believe you call them that. Parallel lines have the same slope. Okay? This is very important information every year in math as you go on and on and on, okay? So because I'm looking at that, because I want to remember my slope-intercept form of a line, what I'm going to do is I'm going to take my 3x plus 5y equals 0, and I just want to solve it for my y. Okay, so that means I'm going to subtract 3x from both sides, and I'm going to get 5y equals negative 3x, and then I divide by 5. So y equals negative 3 over 5x, and the 0 is gone. So if I'm looking at the line I'm talking about, m, the slope here, is negative 3 over 5. So perpendicular to that is m equaling, okay, this one's negative, so this one's positive, and all I need to do is flip it, put the 5 in the top and the 3. Okay, 2 more examples here. Vertical, find the slope of a given situation, a vertical line. Now, when you look into my notes, it's going to say pick points. Well, a vertical line has undefined slope. It's undefined slope, okay? And the reason that is, when I say pick points, think of it, if I took the point, let's say 1, 1, that means that another point, 1, 4, would be straight above it, right? So I'm going straight vertical. So if I plug that in to my x1, y1, x2, y2 formula, what I actually get is I get 4 minus 1 over 1 minus 1. So that slope would be 3 over 0. Now the thing about vertical lines, okay, I never horizontally run, so my denominator is always 0. Anytime we divide by 0, we get undefined. That's why all vertical lines have an undefined slope. Okay, horizontal line. Horizontal lines, on my notes, printed out notes on It's Learning, it says pick points. Well, there's 2 ways. Just depends on the author of the book. You can say a horizontal line has 0 slope, or some authors say it has no slope. Okay, well, let's look at this. Let's pick a point, okay, any point, and let's say I pick the point again. Let's say I pick 2, 2. So a horizontal line, notice my y value is never going to change, so I could pick another point and I could say maybe 4, 2. And then if I came back, because you could plot these 2 points and you're going to connect them, it'll be a horizontal line. You could say x1, y1, x2, y2, and there's an infinite number of examples we could do for these. But in this case, m would equal y2 minus y1 over x2 minus x1. That's going to give me 0 over 2. Bottom line, horizontal lines, you pick any points on that line, you are going to get 0 in the numerator of the fraction. 0 over anything equals 0 slope. Or they can say it has no slope because it doesn't go up or down, it just goes perfectly horizontal. Okay? So that sums up our lesson for the day today. It was just a quick little guy, and from here on out you can go into your assignment pack, complete lesson, try on your own 1-3. Have a great day.